Let's look at another example where we're again asked to solve the right triangle ABC. This time, however, I'm only given two sides of the right triangle. So I'm going to go ahead and sketch the triangle just so that I can see what I've got. Again, I'm going to let angle C be the right angle, and I've got my two acute angles A and B listed. So side A falls across from angle A, so I have 44.25 down here, and I have side B listed as 55.87 centimeters over here. Now, unlike the previous example where I started by finding the missing angle, I don't have enough information to solve for a missing angle. I have two unknown angles. So instead what I'm going to start with is I'm going to solve for the missing side because I have two out of the three sides known, so that's where I'm going to start. I'm going to use Pythagorean's theorem, a squared plus b squared is equal to c squared, to solve for the hypotenuse. So I have 55.87 squared plus 44.25 squared has to be equal to c squared. When I take the square root of that, I'll find out what the answer is. So on the calculator, I have 55.87 squared plus 44.25 squared. I'll take the square root of that. And I find out that C has to be 71.27 centimeters. So 71.27 centimeters. Since my original sides were given to 2 decimal places, I'm going to give it back as 2 decimal places also. Now I have all of the sides calculated or known or filled in. Now I need to figure out what the angles are. This is again where we get to use our right triangle trigonometry to calculate the missing angles. And we want to use SOHCAHTOA based on our known sides. You can see here that the sides that were given to me, and I mean not known sides, I mean the given sides in the problem. The given sides that were given to me are the two legs of the triangle. And so when I have two sides, I'm going to be dealing with, without a hypotenuse, if I'm just dealing with the legs of the triangle, I'm going to be dealing with tangent, just because tangent is opposite over adjacent. So let's take the tangent of angle B. That's going to be equal to, so if I'm looking at angle B down here, that's going to be, we're going to be looking at little b, or side B, over side A in that ratio. So the tangent of angle B, which is what I'm solving for, has to be equal then to 55.87 divided by 44.25. Now it's the angle that I'm actually looking for. So this is where, when we're on our calculator, we are going to use the inverse function. So I'm going to take the inverse of tangent, and I'm going to take that based on the ratio here, or the fraction here, of 55.87 divided by 44.25. So it's inverse tangent of 55.87 divided by 44.25. And that angle measurement is coming back to me as 51 degrees, 51.6 degrees. Now, unless I was given in the problem, unless I was told to give it back in degrees, minutes, and seconds, it's sufficient for us to just return it as the decimal value of 51.6 degrees. So I now know what B is, 51.6, and I can use complementary angles to determine what angle A is. So angle A then has to be 90 minus 51.6, or in other words, when I do that calculation, I get 38.4 degrees for angle A. So this is two different ways of calculating, solving the right triangle. In other words, finding all the degree measurements for the triangle, all the angle measurements, as well as all of the sides using right triangle trigonometry.